Okay, so most of you guys already watched that.
Yes.
So friends who watched that, what was the overall message of this week? What we are talking about? This week it's generally about configurations and release management. What do we mean by configurations? For the configuration management, when we are going through the design of overall system, combining different components, different figures, different functions, we need to have configuration management. Why? Because we want to make sure that it does what it's supposed to do, and the reasons that we are doing testing and quality assurance, right? It makes it easier. So the overall view was, we talked about what do we mean by configuration, why it's important, and why do we need that? Different aspects of configuration management. We learned that we have 3 objectives, 4 concepts, and 5 processes. What was each objective, guys?
I know one was repeatability.
Mm-hmm. So one, it was important to make sure the system is repeatable. Why repeatability is important?
So that if one developer or engineer takes steps on their machine, those same steps will have the exact same result on someone else's machine, and it's more consistent.
Yes. So we need the system be repeatable based on 2 things. One, it saves time. Remember from the project management, we said that we have 3 options, right? We want to have faster release time, higher quality, and lower cost. So repeatability helps us with the faster release time. And also it makes sure that we all have a similar result. So always every steps. What was the next one? Or we can go through that and we see that. So the problems that we need to solve is how big of a project I'm going to work on. Exactly what part of the project right now I'm going to test. How I'm going to manage all the changes. Where are these changes coming from, guys? Remember from last week, we talked about the agility in the market. We said that every time that something changes, we may need to change the requirement design, therefore the entire system. So these changes that is based on the agility, we need to manage them. We need to be able to track them back, right? So the second objective was the traceability. I can trace every change back to know why I did that and who made that change. Then the overall challenges that we are having in SCM. What is SCM short for? Software Configuration Management. Remember when you're Googling, SCM can pops up as supply chain management. Do not go to those links. And most of the time in the market, they refer to SCM as supply chain management. So when you're talking to someone and they may look confused, remember that we have a similar acronym for a totally another word. So the challenges that we have can be different type of changes that we are making in different parts of the configurations. This configuration can be on any site. Can be a source code, can be library, can be a unit, can be the entire system, can be even the hardware. It doesn't need to be software, can be documentation from a specification, for example, right? Each component that we are going to make a change, they may have different dependencies. So when I want to change the entire component, I need to trace it back and change all the dependencies. On the other side, if I want to change one function in one dependent factor or component, I need to make sure that that actually works well in the entire components that I was working on. So another thing is different versions that we're working on. We want to make sure that we are working on the correct version at any point of time. Therefore, we need configuration management. This configuration management goes to different artifacts, right? That we explained in the video. For referring to that, we try to answer different questions. Each questions that we want to answer is 1, if I'm on the right version. 2, how can I track the content of each release? How can I make sure that I have the correct stuff there? Different environments that we are working. We want to make sure that we are working on the customer's environment. Then the quality assurance and production should be the same. If we are working on 2 different environments, it's a failure. What will happen if I need to change some part of a version? How does it impact? And why does something work in one environment, one not? For example, a lot of Python libraries may work on Mac, but not in Windows. That's why when we are going to production side in IT companies, most of them focus on only having Apple products. Rarely we see Windows products in the IT production, software production. So if we are not doing it right, configuration management, we have different symptoms. We have if we don't have a nice traceability of the changes, then we don't know what will happen. We are losing them. We may take a longer time for release. We have bugs that we didn't understand and it broke the system, so on and so forth. So it is beyond just the testing. We need to go step by step. But what do we mean by that? The definition that comes from software engineering body of knowledge says configuration management is a discipline that identifies all the changes and try to control the changes, and also works on integrity and traceability. We know what do we mean by controlling the change. What do we mean by integrity of the system?
The system works as we expect it to.
The system works as we expect it to, based on the requirement. And what do we mean by the traceability of the system?
We can link what it does to the requirements.
Yes. Also, we can trace it back step by step for different versions, right? So we can track the changes as well. That is used under information technology infrastructure library that talks about different processes, procedures, tasks, and checklists that we need to do for the configuration management. And the context of configuration management is focused on maintaining information rather than actually development. So we already know that when we work on configuration management, we try to centralize all the information. That's why we have a database there. Every time that we create a change, we save that there as well. We have always a copy there, so it maintains the records and lineage of all the configurations that we changed. With that, now we can focus on the objectives, concepts, and processes. From the definition, what was the object? One was the repeatability that Dave said. What are the other two?
Traceability and integrity.
Exactly, traceability and integrity. So we want to make sure that system is repeatable, then it's traceable, and then it has the integrity of what we want it to do. And it's always a parallel dynamic relation between control during the development and during the operation. At both parts, we need to look at all those three objectives. In the development, we look at improving the production and prevent from different attacks. We have clear traceability. We understand why we changed something, what version. In the operation, we mostly focus on the integrity of the system and the repeatability of the entire system. On the other hand, when we are looking at the solutions that we want to work on, depends on the size of the system, we should pick different type of solution. If you remember from last week, we do not have just one type of solution. We always have a hybrid. We combine different type of methods together, right? When I'm looking at a very small project, the solution is very simple. It's 2 or 3 developers. We can easily manually trace everything. But when I'm working with a complex project, I need to have more complex management method to work with that. So I need to pick the solution based on the size of the project that I have. One thing that we want to make sure is when we're working on the configuration management, often it happens that we focus on controlling the change than if this change is actually successful. And that's a huge problem that a lot of time happens. Then we have 4 different concepts. So what is the definition of baseline? What do we mean by baseline?
A baseline is sort of like the first set of configuration items that are established that everyone agrees on, that the configuration process starts from.
Yeah. So baseline can be defined as the smallest unit of any part of the system that everyone officially agreed on that. If we want to change a baseline, what should we do? We should go through an official change control situation, right? What do we mean by configuration item? The smallest unit of each component is configuration item. Remember, a baseline can be a configuration item. A configuration item does not necessarily mean that we have a baseline. So first we define a configuration item, and then based on that we can define a baseline. But once I have a baseline and I keep updating that, then I only have a configuration item. Then we had a version. What is a version?
A version is some sort of identification to track changes that have been released to production.
Mm-hmm. Every different release that we have, we can track the changes on new release that creates a new version. For each version, either we have a big version or we have the smaller part of the same version that we are updating. And what was the change control? A change control was the meetings that we had for understanding if we need to change something, and then we update the baseline, right? So remember that baseline is something that we formally agreed on that. We first have a configuration item. We agreed on this is going to be our baseline, so we claim that. Then every time that we need to change, we need to go through change control board or meeting or committee, then we update that and we have a new baseline. So I cannot just go and update the baseline to create a new baseline because it is already formal official. For the configuration item, the smallest unit, the lowest unit that I have is a configuration item. So a baseline is a configuration item, but just having a configuration item doesn't mean that I have a baseline. From top level to bottom level, the size of configuration items are different, right? So if I'm starting from the lowest part, a code has a configuration item, data has a configuration item. Therefore, when I'm going for user interface configuration item, it already can be decomposed to different, smaller size configuration item of subsystems that I have. So in a project, I have different subsystems, for example, in user interface as one subsystem, I have another subsystem that works with the code, another one for my database, another one my unit tests, right? Each of these subsystems has a configuration item, then they combine and create another configuration item for user interface. Then we had a version. We had three difference. We had version, variant, and release. Version means the instance of each configuration item that functionally are different. Variant is the instance of system that functionally are identical, non-functionally are different. And release is the instance of system that is distributed to the customer or end users, and they have a version numbers. Again, version is based on configuration item and functionally are different. Variant is based on systems, functionally is the same, non-functionally are different, and release is the entire system that I distribute for end users, and it has different version numbers, meaning we have different functions, or functionally they should be different. And we can always trace back different versions based on the configuration item version ID that I create. That helped me to understand what I changed, why did I change that, who made the change, and when that change happened. For complex big projects, we can use different tools like GitHub, Apache. In this class, we are working with GitHub, and we are for testing, we are, I forgot the name, we are getting there. Then we have a change control. Any requirement that changes, not be haphazard, we can do that. So the changes that makes before the baseline are easy. Why? It's not formal. We just decided that to try, see if it's working better. But as soon as the configuration item submitted as a baseline, any type of change that we want to make forward, it must go through a change control. In the change control board, we need to explain about why it's desired. Does it work or it does not work? Is it compatible to other changes from different parts of the system? And how can I make sure that I have a minimum risk for the system failure? Then, okay, the summary we just did. Then we have a management process. In management process, we have change management, configuration identification, software build, release management, and status accounting. What do we mean by change management?
Is it something that's very similar to change control, just like a formal process to make sure that changes can be approved or denied?
Yes. Change control is the act. Change management is the board or the committee who actually review the act that we want to do. So it helps us to track the changes that we are doing, decide whether it's good or bad, and we ensure that the quality is high and we have everything under the control. When we have a change management for change control, we need to create a request ID, change request. For change request, we must have a change request ID. Why? So we can trace it back. We need to explain what is the change that we want to do. We need to propose how we are going to do that, who is going to do that, when it will be needed, and what are the risks that if we do this change, we need to do. And then we have different people. We can have a project manager, project owner, I don't know, customer, developer, tester, everyone. Based on the size of the project is different. So it's a simple control flow. We need to make a change. So we create a change identification control item. We have an ID there. So we generate the request for, we submit that. It will be evaluated. If it's incomplete, we again need to resubmit that. If it's complete, it goes under the investigation. Based on the committee board investigation, either it's approved or rejected. Rejected, case closed. If it's approved, then we assign that to different engineer to work on that, and then we schedule when it's going to be released for test and other managements that we need. Remember that for change requests, we have two different types of change. Either we have a change with low severity, high priority, or we have a change with high severity, low priority. Low severity, high priority means that something that directly impacts on people's life or people's income, but not very much with the company. High severity, low priority means that we are not responsible for or we are not creating any damage for any person, but it directly works with the company. Remember the example that we had? Imagine when we are creating a website to sell a flight for around the world. Low severity, high priority would be what? I assign wrong labels to different flights. Instead of going with Emirates and Turkish, I go with JetBlue and Delta, but then the price is different. So that is high priority. The wrong logo is not that important, that the price is important because I'm losing the customer. When I'm going for high severity, low priority would be like what? If the low priority would be, what was the example I gave you? The color, for example. The logo color is wrong, so that is a low priority, but still it is, instead of Emerald, I have Delta, and the logo color is wrong. So the priority is I should update the Delta to Emerald. However, instead of showing it in red, I show that in blue. So the blue would be low priority than the actual label or logo. So for tracking, we are using different configuration request systems. That for us, GitHub is the best one because it does everything automatically by itself, but we have different type of systems out there. And everything's happened in change control review board. That's where the control management is going. They decide on approve, reject, or postpone. Practically depends on the project, and everyone practically can be part of the team based on different companies, different policies, and size of the project. In Agile, request management is easier because we do not need to have change control board. My product owner can actually decide if I want to do a change or not, and every 2 weeks for the sprint, they can release that, and we can daily talk about that. Then we had configuration identification. What do we mean by that? We mean that we want to have ID for each configuration item, right? It's the process that identifies the attributes of every aspect of configuration item. So again, remember, configuration item can be a baseline, but baseline can not necessarily is a configuration item that I'm working on. So I need to make sure that everything is documented based on different IDs that we have. This process helped me to make sure that I'm on the correct version. I can recreate whatever I needed in the same component, and I have a baseline to compare because I can trace everything back based on the ID, right? The challenges that we have is practically how I'm going to name this configuration item, and why I want it to be something that it means it will be meaningful and it will be easy to follow. We have different models of naming. One, we can do version identifications that we use the name of a schema and a structure of the configuration item. For that, we're doing unambiguous ID that we can very much expand to different configuration items. So we can use version numbers, attribute-based, and change-oriented identification. For the version numbers, we have multiple unique versions. For example, we have version 1.2, version 2.00, stuff like that. For attribute-based, we assign to associate version of the attribute. The examples can be, we have the date, we have the creators. For example, I say version date September 15th was. So that show that who did that. And then for the change base, every time that we change, we are adding a new version. So it goes on used for the system mostly rather than the component. What we do in this class, we are following the schema. We have X, Y, Z. X is a major software release. I am in version 2. Then Y is the minor software release. During software version 2, I am in third release that I'm going to update. And then I have a patch release, emergency software that I was fixing. For example, I have version 10, 12, 6. So my major version is 12. Then I have minor version is 10, minor version is 12, and the emergency that I needed to update was number 6. For the APIs, we can do the semantic version. It's practically the same. We do major, minor, patch. There's not very much difference between this one and the previous one, really. And in GitHub, we can do everything automatically. We already know that Git is a distributed version control that works on the cloud. We are online. We can have access to everything. It wasn't originally a tool for only storing the source, but right now we are using that for configuration management and development. And it's very widely used in open source. Any questions still here, guys? Just want to make sure that we have enough time for 1 hour to go to everything. Oh, why did that? I didn't mean to do this. Okay, because I know all of you already work with GitHub. What is the difference between master and the branch?
Master is the main branch and the main source of the file. Branch is when you wanted to make a change to that, you create a branch and then start modifying it. And when the testing is done, you merge it back to your master and release it as the final version.
Mm-hmm. So what is the best practice every time that I want to update something, what I should do?
Me personally, I create a branch and work on the branch, make sure that things are working properly, and then I integrate it with my master and then release it.
Okay, so every time that we want to make a change, we need to create a branch and work on that instead of directly work on the master branch. Then when we are done, what should we do?
Create a pull request so that it can be reviewed.
Yes. And then when it gets reviewed, what will happen?
Run automated tests on the branch.
Then when I'm doing the push, when I'm doing the commit.
So when we are satisfied with the testing, we just make a commit, pushes something, you publish it on the net, like the website or the GitHub repository. You just go and update the repository.
And then when I update the repository, does it directly go to the master branch, or I still need to wait for the pull request?
Typically, you still need to wait for the pull request to be merged in before the changes will be made to the master branch.
Yes. Okay, so we have a master branch that is the very main one. We create different branches. We update whatever we wanted on that. We commit, we create a pull request, and then we push to the GitHub. We wait for the pull request. My product owner or master, Spirit master or whoever is responsible will review the change. If they approve, then it will be added to the main branch. So this story was correct, right? On the other hand, we have a couple of other stuff. One is the wiki, is where I can add the documentation. Then we have a clone. Not every time we want to work online. When I'm working on a repository, I can download that for myself. So I can clone a copy of repository on my local machine. We can merge different branches. So if I have couple of branches that I created, or I have a couple of different developers that all of them send pull requests, I can merge their branches together and practically to the master branch. And is there anything that we forgot to talk about, guys, here? I don't think so. Okay, so a commit in GitHub is a configuration item. Every time that we commit something, we created a new configuration item in configuration management point of view. So the next one was software build. For building a software, we have different methods. Either we have a traditional way, everyone is working parallelly, and then they wait for end of the phase, so they are ready with what they are doing and they're going on, or we are doing that with Agile. Some places or some systems like GitHub is very well designed for Agile. In Waterfall, as we knew, or in deferred integration, when your code is ready, you're submitting that, then you're waiting for all the code to do the integration, then you do the test scheduling, then you do the testing the system, then you deploy the system that you have. When we are working in Agile, that under GitHub, we always mostly working with Agile. Every time that I'm ready, I just make a commit, and then it's ready for integrate and test as soon as the pull request is approved. So we have a constant release that we can do. For the continuous integration flow, we have a code repository. Everyone is working on that code repository like what we are doing in GitHub. So this code repository has automated testing. And after the testing is done, we can start doing the integration and we build the entire system. So the best practice was we always maintain a single source code. We always have one master, then maintain non-source code artifact in a binary repository. We create automated build process. We do automated testing. So every time that I commit something, it's already be tested because it's automated. We do the frequent code commit. Why? Because everyone is working on the same single unit code. So we want to make sure that everyone has access to the newest version of the code. Then we build and test the deployment environment, not just in whatever we wanted to do. And we fix the problem as quick as possible. As soon as I do a function, I make a commit, I tested that, and when it doesn't pass, I go back and fix the problem. I'm not waiting for the next part that I wanted to test. The benefits was it reduced the risk, it detect and fix the bug very quickly, it converge on a solution more quickly so I can understand it better. I have fewer bugs because every time that I tested it next time, I only need to make sure that the new functions is actually working well, and it enables continuous delivery to the customers. I'm always ready to deliver. Yeah, I remember. That's Travis. For doing the automated testing, we have different systems in this class. We are working with Travis. The reason is it is hosted on GitHub. It's very easy to fix and install, and you can easily work with that. And of course, it's open source. What else? We have different environments that we are working on. We have a development environment, integration environment, system test environment, and support environment. When we are doing the testing and we are in the configuration management, we always make sure that we do the job at each phase in the correct environment that we want. And when we are doing the deployment testing, we always make sure that we do the test in the environment that the customer is using. Then we have a release management. Release management is when the overall process is done and I'm ready to be deployed. I want to go for the market. I'm going to manage that. There is always an optimum speed. If I'm very slow, I'm losing the market. If I'm very fast, I may have a lot of bugs that I didn't get enough time to respond back. We never can say when is the right time. It's always a combination of those three factors: the quality, market, and the cost. And sometimes the policy that comes with the company as well. So we have three different levels of the release. We have a major release, that's a major version, from version 1 to version 2 to version 1 to version 2. Normally it takes between 6 to 12 months. Then we have a minor release. Inside each version, when we are going towards the next version, we are updating different functionalities. That takes between 1 to 2 months that every time we have. And we have an emergency fix. Something happened, very high priority, we fix it and right away we go to the market. This was an example of Mac OS releases between 85 to 2017. As you see, for different projects, it takes different time. And for the Finder, it was taking the entire time. But for classic OS, it started from 84, and then somewhere around 2002, it stops in version 9.19.2. On the other hand, it's more than just a software. Every time that we are working, we need to look at different installation, the system operation, system target, documentation, marketing, people that we are working on, different hardware that we need when we are going to a new version. So it is not just a new version of a software going on. For example, in Pixels, in Pixel 1, when they were, this happened around like 2018, they had a minor update. I don't remember which version number it was, that suddenly the camera didn't work. So they had to fix it. So it wasn't just the software. It didn't compatible with the Pixel hardware itself. So the issues is, from the development side, too many releases cause cost and too many churn. The release not tested sufficiently, so we have buggy system, and late release, we are losing the market. From the customer support, if we have minimum number of support release, then the customer would not trust us. The customer may not want to upgrade from version 1 to version 2, so that creates a problem. And that's why normally when every other version, they put a deadline. For example, they say that if I'm releasing version 9, then version 6 will be stopped getting support in 2 months or something like that. And a customer may skip intermediate releases when they're going after 2-3 release update for the newest version. Then they may have some support costs that they need to pay. In Agile, the release is like a train. Every time that the train arrives at the end of each sprint, each scrum, there are some new tasks that go in and the release comes on top of that. So we have a train that every time I have a new pack of the release going on and the new pack that coming out. So when it's coming out is a new release. The one that is going on the train is what I want to work for the next release. On the Spotify, they are doing something called that toggle. They know per each week or per each sprint what they want to work on. So they assign that. And if they're done and the function is working, so in the release train, this thing started working. If it is still not completely working, for example, task D in the first week, then they show task D, but it is malfunction, it's not working. So this task D is feature toggle, that it is there, end user knows and will be waiting for this new feature, but it doesn't work at the moment. In the DevOps that we have continuous development, we have the same idea. Every time that I'm changing something in the integration, I try to update that in the development as well, and we will have release. And then from there, I'm doing updating the automation testing that we have. So in the DevOps, we have continuous development, testing, integration, delivery, and monitoring. Therefore, automation is the critical part. If I fail in automating my testing, then I'm failing in actually delivering a nice DevOps job. In practice, DevOps tools have source code that goes under the configuration management. We start building different tools for different development, deployment environment, and we need to have automated tests that goes for all level of testing, for unit testing, integration, system, performance, so on and so forth. And the last one is the status, accounting and auditing. What do we mean by that? By auditing, it's going to the integrity again. Every time that I do a release, I look at the system and I'm making sure that it's matching with the baseline. That helps me to improve the security, maintenance, and so on. For the accounting is every time I look at the agility, every version that I have, how much change I had, how much it evolved in the market need. So that can help me to record the documentation and agreements that I need. So any questions on the configuration management and any part of that?
Yeah, I have one question.
Yeah.
So a lot earlier, you mentioned that a potential problem with SCM is when it becomes the objective rather than control becomes the objective rather than delivering a quality product.
Like this, yeah.
Do you have like an example? Like, how would you identify if that is currently occurring in your project?
See, for example, I'm just making up this example. I don't have any industry thing in my mind, but one thing that may happen is when we are going through the control change management, we're focusing a lot on what change is necessary and why we should do that. They actually take longer time that I'm losing the release time. So my focus was on the change, not on the success. The success would tell me that I need to put half of the time, or I need to not be very fussy about half of the changes. For example, if the change is the change in the color of the background, it doesn't really need to take a lot of time, for example. But then we argue over which color we wanted to have and why we want to change that. I will think about more industrial example, and by next week I will share one of those examples. I'm sure there should be something in the house that I will find that. Okay.
Thank you.
So, and anybody else has any? No. Okay. Containers, guys. What is the container? Remember from last week. What do we mean by container, or practically Docker that we talked about?
It's like a self-contained environment for a project that contains all of the libraries and all the configuration settings, and it can be shipped on its own.
Exactly. So the idea of the container comes from the logistics, like sea or water shipments, right? So everything that are similar, or everyone who needs to work on the same project needs to work on the same environment. We can create that environment per project or per component of the project in one container. The combination of all of the containers together can create the entire system for me. But inside each container, I have a similar to, or maybe we can call that a virtual environment with all the requirements that I need to create that component, and everyone who's working on that component has access to that virtual environment. So we are managing that environment challenge that we have. So we can deliver as a collection of different Dockers that create the system. Each of that, I have the application, I have the library, I have the Docker engine, and I have the host. So like Git, that it has GitHub, Docker has a Docker Hub as well. And then it easily can be installed on different IDs that we're working. For example, if you're working with PyCharm, it's just a click to link that to the Docker and start working on different containers. Another thing that we want to know is all of the libraries or requirements that you're adding to a Docker, we call them, I create an image. I copy this requirement that I want, I paste there or I install there. So I have an image of the requirement that I needed. So any questions on what this week material was about? I try to very fast and quick cover everything again. We are good here. Now let's go to the homework. Anyone has any problem with previous homework or this week homework or quiz or whatever that you're doing right now? I don't know, the discussion.
Well, Professor, I have a question.
Sure.
So I actually don't have a background in coding, so Python is relatively new to me. I'm just kind of wondering, how complex are we going to get with some of the coding? Like the triangle stuff wasn't too bad, and I'm really new to unit testing, so using what we use for unit testing was a little new to me. So I just kind of want to know, how complex are we going to get with some of the homeworks? Because that took me kind of a lot of time just to kind of figure out itself, come up with the solutions. Okay,
the unit testing is the most complex level of the Python coding we are going to have. Normally, the questions or the program that I want you to create would be very simple because the focus is not the program is simple, but you don't need high level of the coding for that, since the focus is on the automated testing.
Okay.
Yeah. Do you have any other language that you feel more comfortable with besides Python?
I mean, I kind of basically been exposed more to Python because I don't have like a CS background, but I do software testing, but it's more embedded testing. So I've never really been exposed to actual looking at coding and testing. So
okay,
that's kind of why it's a little new to me with some of this. The concepts I understand, it's just like the actual like coding part is like I don't know part. So that's the part that's time consuming for me. It's like syntax and all that stuff.
Yeah, I understand, and it takes a little bit time to get familiar with. That is good that you let me know. So now we know how details we should go to your codes. Anytime that you needed help, just email me. Another thing is, guys, we are going to have 2 TAs. I will update the homepage with their names. Even you can contact them and ask for their help as well. Okay. It's totally okay. Just remember, when they are helping you and if the code comes from them, just put a comment reference. Ross helped me with this part. So we don't think it was a cheating. We have a reference there.
Okay, all right.
Yeah, sure. Yes, Gabriella.
For the Docker management homework, we use other sources. I know you say that our response shouldn't be any longer than a page, but can we go on to 2 pages if we're citing sources?
Yes, you can. And do not forget to citing the sources. I mean, the citation doesn't count on your first page. Okay. Any other questions about the homework this week? If not, we have 4 minutes. Let me talk about friends who joined a little bit late. If you miss 1 or 2 weeks, you are going to have 1 week extension. Meaning, if instead of from the beginning of the class, like you miss the first week of the class, the homeworks for the first week of the class, you have time to submit 7 days after that. If you we have 2 friends who just joined on Tuesday, and yesterday, one actually I get an email today. So you missed 2 weeks, therefore you have 2 weeks to submit.
Yes, Professor. I just joined. This is my first lecture today.
Okay, so that means for you are doing your normal homework. Okay, and then the first week homework that you are missing the deadline,
Yeah.
the first week of joining the class, you should submit that. The second week of you joining the class, meaning you join in week 3, right? So in
Yeah.
week 3, you submit homework of week 3 and week 1. In week
Okay.
4, you submit homework of week 4 and week 2.
Okay, cool.
Yeah.
Perfect. Thank you so much.
Professor, what if
Yes.
you're going on travel? Like I'm gonna actually be away out of the country from the 30th of September to 6th of October. Do we arrange for extension?
Yes, our agreement was before the deadline, email. If you have a date in your mind that you will be like, I don't know, Roz, on October 20th till November 3rd, I'm not around, so I can make all the submissions on November 10th. I will postpone that to November 10th. If not, then, I mean, if you do not give me a date, then we can talk about that and see when you can submit that. But if you don't give me a date, normally I automatically give you extension for 72 hours. If you have a date that like you are not around for 2 weeks, bring that to my attention so we can work on that. But email me before the deadline.
Yeah, I'm leaving the 3rd, so I will probably email you next week.
Okay,
with,
great.
details.
That is great. Okay, any other?
Yeah, hey
idea?
Professor. Yeah,
Yes,
Professor,
hello.
yesterday only you have sent me an invite for an observer,
Mhm.
but I can't able to like access all the assignments and homeworks as an observer because whenever I'm trying to click any assignment, it's just showing we can't open. I can send you the snapshot
Yeah,
also.
I know. Unfortunately, I do not have any other options for you till you are officially registered. What I can do is I can send you the homeworks like manually. You start doing them, and as soon as you are registered, you just submit them.
Okay, Professor. Thank you.
Sure. Okay, any other? Another thing for friends who are working, like Alan, I know you're working and right now you're on a trip. This Q&A is suggested to be participate, but Web Campus doesn't have any participation. Therefore, I will record everything and put a video. If something goes wrong that you couldn't show up, do not feel that you missed a participation grade or something. I will put the video on. However, I would love to see you guys and talk to everyone. Just, I'm sorry that I'm not teaching in person this semester. I was looking forward to that. Okay, so any other concern or questions or?
Yes, this one question, Professor.
Sure.
When you're saying citing sources, does that mean just listing the websites that we use for the Docker?
Yes, exactly.
Okay.
Yeah. I mean, when you do that, for example, you have a first paragraph from Wikipedia. Okay. First, you need to rewrite that with your own word. And at the end of the paragraph, you put a parenthesis, put number 1. At the end of your stuff, number 1 is the link to the Wikipedia that you have.
Oh, okay. So like numbering in the actual.
Yes, in the actual
okay.
referencing format.
Oh, okay. All right. Thank you.
Okay, guys. Great. So see you next week.
Thank you, Professor.
Thank you, Professor.
Have a great one, guys. Bye.
Thank you, Professor.
Thank you,
Bye.
Professor.
Thank you.
Have a nice one. Bye.